Welcome to Electronics Excel. You are watching previous questions of digital signal processing. So, in this lecture, we'll see one long time questions. Okay. This is asked in the 2022-23 examinations. So, the question is here: use overlap add and overlap save method to find the long division convolution between the uh, means x of n and h of n. So you can see x of n is given, it is a long sequence, and h of n is the impulse response. So you have to find out the uh, convolution using the overlap add method and overlap save method. Okay. So we will see first the overlap add method. Okay. So in this case, let us assume that the input block length is L equal to 4. So you have to partition this x of n into block of 4s. So you can take any data of length. Okay. So we are assuming that this block length is your L equal to 4 here. Okay. So block length L is not given in the question. So we have chosen the block length equal to 4. Okay. So because if we check the block length is larger, you can have fewer number of computations. Okay, if we choose block length, it means fewer size of block length, that will be more number of computations will be there. Okay, so again you can choose depending upon you. So you have chosen this block means up to 4 means you can partition this block up to the 4, this x of n into 4 block size of L equal to 4. So this is 4, then this is 4, this is 4, and this is 4. Okay, so here partition this block into means 4 number of sequences. Okay, x of n. So into fewer blocks. Okay, so you can see. So let us begin our discussion. So length of the impulse response, that is m, equal to 4. So you can see m is 1, 2, 3, 4. So m equal to 4 is given. Okay. Now in the overlap add method, what we have to do is that we have to partition this block, okay, into block size of L equal to 4. So what in this case, x1 you can choose. Okay. So we can append, you can see in this case, so for number L is the, you can take L data points. Okay, this is the L data points. Okay, so these are the L data points. Okay, then these three numbers you can see zeros. Okay, means you have to append m minus 1 zeros into x1 of n. Okay, so m minus 1 zeros is you have to append, means m is here is your 4, so number of 0 you have to append is your 3. Okay, so total is your 4 plus 3, so this x1 of n is size of 7. Okay, so you can see three numbers of data we are adding from x of n, then m minus 1 zeros you have to add. Okay, next, for finding out x2 of n, similarly for number of new data, that is this one, 3, 1, 0 and 1. So 3 number of data, that is 3, 1, 0, 1. Similarly, 3 number of 0 you have to append, it is m minus 1 zeros. Okay, same for all the blocks. Okay, so x3 of n, that is 2, 1, 0, 1. So 2, 1, 0, 1 is the new data. Then m minus 1 zeros you have to append. So 3 number of zeros. Okay. Similarly, x4 of n, that is the 2130. So 2130 is the this new data. Then you have to append m minus 1 zeros. Okay. So the size will be same, x1, x2, x3 or x4. Okay. Similarly, 1 is remaining. So you have to 1. This is the new data. So these are the new data. 1 triple 0 you have to append. Okay, to make the size same. Okay. Similarly, m minus 1 0. So we are appending m minus 1 zeros. Okay, and L equal to here, how much L equal to 4. So this is our, we have divided x of n into these blocks of data. Okay, now you have to do the circular convolution for each of these inputs. Okay, so what is the size of this one? Is the total x1, x2, all the size of 7. So you have to make h of n also at the size of 7. Okay, so let us check that. So h of n is given is 1, 2, 1, 2. So you have to append 3 zeros to make the same size, because you have to find out the circular convolutions. Okay, so that having each length will be equal. Okay. Next way we have to calculate the circular convolution, that is y1 of n. So x1 of n circular convolution is h of n. Similarly, so on so forth. Okay. So let us take this. So what is y1 of n? That is x1 of n circular convolve with h of n. Okay. So this is the x1 of n. Then you have to this convolve with it with h of n. Okay. So this is our circular conversion, we have used here the matrix multiplication method. Okay, so this method is called the matrix multiplication method. Okay, so you can write over here. So this sequences 3 1 1 1 1 up to 0, then this 0, then this 0, this 0 comes over here. Okay, then you have to write in sequence. So this 3 1 1 1 likewise. Okay, then this 0 comes over here, and the sequence will be this. You have to write this way. Okay, so then this 0 will be there. Okay, then this will be shifted. Okay, so likewise. Okay, this one which comes over here, then the sequence will be written this way. Okay, so now this one, that is one, then the sequence will be written this way. Okay, so likewise you can take, so it will be this x1 of n, you can multiply with h of n. This is our h of n. Okay, then you have to multiply, that's this, so that will be this 3 will multiply with this 1, then 0 multiply with 2, 0 that will multiply with 1, then 0 this multiply with 2, then 1 that will multiply with 0, so that will be 3. Similarly 1 this multiply with 1, then 3 that will multiply with 2. Okay, then 0 0 0, so 0 0 0, so all are 0, that will be 7. So likewise you can cross means multiply the matrix. So this is our y1 of n. Okay, similarly you can find out y2 of n. Okay, so y2 of 1 is the x1 of t circular converse with h of n. So similarly this is our x2 of n, that is circular converse with h of n. Okay, now this is this 3 1 0 1 0 0 0. Okay, like we have done in the previous means y of 1 of n. So same you can do over here. So this is the matrix multiplication. So this 0 then comes over here, then this 3 1 likewise. Okay, then this 0 comes over here, then all the data will be shifted like this. Okay, then this 0 comes over here, all the data will be shifted like this. Okay, so likewise you can do. Okay, so this is our h of n, so then you can multiply, so this is our y2 of n. Okay, similarly you can find out what is y3 of n, y3 of n also x3 of n, circular conversion to h of n, so that is the circular conversion using matrix multiplication method. So we can find out this is our y3 of n. Okay, similarly y4 of n, so x4 of n circular conversion to h of n. Okay, so this is our x4 of n, then circular conversion with h of n. Okay, then it will be this is circular conversion, so it will be y4 of n. This is your y4 of n. Okay, similarly y5 of n. Okay, this is our x5 of n, circular conversion with h of n. Okay, so this is our y5 of n. So we have calculated y of y1 of n up to y5 of n. Okay, so now this is our y1 of n, then this is y2 of n, y3 of n, y4 of n, and y5 of n. So these are the this is means y1 of n. Okay, this one is your y2 of n. Okay, this is our y3 of n, this is our y4 of n. Okay, then this is y5 of n. Okay, so now this is our overlap add method. Okay, so you have to add means you can see over here. So m minus 1 points you have to add. So y of this, these are the m minus 1. M is your, here is your this m is your 4. Okay, so m minus 1 means 3. Okay, so m minus 1 is your 3 means you can see this is your m minus 1. Okay, this is your m minus 1. This is m is equal to 4. So 4 minus 1, that will be 3. So 3 data points. Okay, these 3 data points will be added to these 3 data points. This is also m minus 1. That is 3 data points. Okay, so likewise these 3 data points will be added to the first means first of y for f. Okay, so these 3 data points will be added. Okay, similarly this last of 3 data points of y3 of n will be added to the first of 3 data points of y4 of n. Similarly the last 3 data points of y4 of n, that will be added to the first 3 data points of y4 of n. So likewise. Okay, so you can see that this last 3 data points of y1 of n will be added to the first 3 data of y2 of n. Similarly the last 3 data point of y2 of n will be added to the first 3 data points of y3 of n. That is, last 3 data points of y3 of n will be added to the first 3 data points of y4 of n. Similarly, last 3 data points of y4 of n will be added to the first 3 data of y5 of n. So this is because m minus 1 data points we have to add. Okay. So you can see this 3, 7, 6, 10. So this is 3, 7, 6, 10. So this 5 will be added to 3. So 5 plus 3, that will be 8. Okay. Similarly, 3 plus 7, it will be 10. Okay. Similarly, 2 plus 5, that will be 7. Okay. Similarly, this 8 written as it is. Okay. Then 4 plus 2, it will be 6. Then 1 plus 5, that will be 6. Then 2 plus 4, that will be 6. Next 6 is remain as it is. Then 4 plus 2, it will be 6. Okay. 5 plus 1, that will be 6. Then 7 plus 2, it will be 9. So 11 as it is. Okay. Then 5 plus 1, it will be 6. Then 6 plus 2, it will be 8. Then 1 plus 0, it will be 1. Then 2. Okay. So likewise, you can 8. Okay. So total number of output will be, you can see according to the formula. Okay. Let us what is the formula? So n equal to L plus m minus 1. Okay. This is the formula for finding out the means output length. Okay. So L is the x of n, length of x of n, that will be, that is given as I think 17. Okay. 17 plus this is the impulse response length, is at 4. That it will be 1. So total will be 20. So output will be of having length 20. Okay. So this is the length of x of n. Okay. This is the length of h of n. Okay. So total is 20. So you can see this is length y of n will be, total length is 20. Okay. So no need to write down this 3 zeros. Okay. So this is how you calculate the using the overlap add method. Okay. So let us see the next method is your overlap. The same question. Okay. The overlap same method. So similarly, let the length of the input block is your 4 and the length of the impulse response equal to how much? It is 4. Okay. So using the overlap add method. Okay. So we are using the overlap add method. Okay. So in this case, what will happen is that similarly we have to block the data into the 4 points. Okay. So let us check, that is the overlap same method. Okay. So let us check that. So 4 points you have to same method. So you can see over here, you can see. So these are the m minus 1 zeros you have to add. Okay. So m minus 1 zeros means there will be uh, uh, so the new data points is this one. 4 having length is 4. Okay. So you can see this is the length of 4. So this is the new L points. Okay. So this is the L new data. Okay. L new data. These 3 are appended. M minus 1 zeros first you have to append. So there are 3 zeros you have to append. Okay. Similarly, what is x2 of n? X2 of n similarly, you can see this last 3 datas of x1 of n that we have taken. This last 3 datas, this 1, 1, 1. Okay. So that is the m minus 1 means 2 last 3 datas. Okay. So this is the m minus 1 datas of the x1 of n. Similarly, this is the new L data points. These are the L new points. Okay. For x3 of n, similarly, this 3 data 1, 0, and 1. Okay. 1, 0, 1 will be taken of x2 of n. Okay, according to m minus 1 data. Okay, m minus 1. Similarly, this is the L new data, 2101. This is the 2101. Okay. So next is your similarly x4 of n. So last 3 data will be 101. So 101 last 3 data. Then it will be taken, new data is your 2130. Okay. Then last 3 data of x4 of n, that is 130. Okay. So 130 is the last 3 data of x4 of n. Then it will be new data will be added. So this new data will be 1, and this you have to append the 3 zeros because you have to make this all the sequence will be having the same length. Okay. So m minus 1 data first you have to append the m minus 1 zero first, then 4 new data. Then this last 3 data of x1 of n, that is 1, 1, 1. Okay, these are the new data of x2 of n. Okay, or first data of x1. Then for new data, that is 3101. This is 3101. Okay. Similarly, last 3 of x2 of n, that is 101. So 101. This is according to the m minus 1. Okay. So then next for new L points. Similarly, 101. The last 3 data point of x3 of n. Okay, then for new data. Similarly, so on so forth. Okay. So now h of n equal to, you have to make the same size. So it is 1 2 1 2. Then you have to add append with 3 zeros to make the same size, because we are using the circular convolution here. Then you have to do circular convolutions of x1 of n with h of n. Similarly x2 of n with h of n, and so on so forth. Okay. So this is the overlap same method. So this is x1 of n circular convolution with h of n. Okay. So this is our x1 of n. Then this is our h of n. So you can using the matrix multiplication method. So you are using here. We are using matrix multiplication method. Okay. So same that we have done in the previous case also in the overlap add method. So you have to find the circular convolution using the matrix multiplication method. Okay. So this is our y1 of n. Similarly, y2 of n, x2 of n, circular convolution with h of n. So this is our x2 of n, circular convolution with h of n. Okay. So this is our using the matrix multiplication method. So this is our y2 of n. Okay. Similarly, y3 of n, so x3 of n, circular convolution with h of n. So this is our x3 of n, this is our h of n. So you have to find out the circular convolution using the matrix multiplication method. Okay. This is our y4 of n. Okay. This is our y4 of n. Okay. Now y5 of n. Okay. So we have calculated all y1n, y2n, y3n, y4 and y5. So these are the all the data. Okay. So this is our uh, y1 of n. Okay. This is our y2 of n. This is our y3 of n. This is y4 of n, and last one is your y5 of n. Okay. So how to calculate the circular cone using the overlap same method. So this is our output. See, you can see the whether you are doing overlap same method or overlap add method. Okay, both will be same. The result will be same. Okay, whether you can also, but you can take any length, a block length, whether it be 3, 4, 5, 6. Your answer will be same using the overlap add method or using overlap same method. Okay, so that you have to check. Okay, so now how to write? You have to discard. In this case, you have to discard first m minus 1 data points. Okay, so you can see m minus 1 data points you have to discard means uh, so this 5 3 2 is not taken over here. So this is m minus 1. So 3 data points we will discuss. That is why it is written as you can see 3 7 6, okay, and 10. 3 7 6 10. So 3 7 6 10. Similarly, y2 of n you have to discard 3 data points. So 5 4 6 we have discarded. So what we are left with 8 10 7 8. So here is your 8 10 7 8. Similarly, y3 of n 5 3 4 will be discarded. That is m minus 1 data points. Then the output will be 6 6 6. You can see 6 6 6 6. Okay. Similarly, first 3 data points of y4 of n also discarded, so it will be 6 6 9 11. So 6 6 9 11. Similarly, 1 5 7 it will be discarded of y5 of n, so it will be 6 8 1 2. So 6 8 1 2. So here we are discarding this. Okay, first 3 points. First 3 points will be discarded. Okay, it is m minus 1 data points will be discarded. Okay, so we are left with this one 3 7 6 10. Then 8 10 7 8, then for number of 6, then this is 6 6 9 11, 6 8 1 2. Okay, so I have seen actually all the outputs will be same. You can see whether you are doing overlap add method or overlap save method. Okay, so this is our 1 6 16 more questions. Okay, so these are the references. Okay, for doing these problems. Okay, so thank you for watching this video. If you have any doubt, you can keep asking in the comment section. We'll see in the remaining long question in the coming videos. Okay, so thank you all. So have a nice day.